So I want to start off with a little bit of a quick review again, making sure we remember how to calculate the values of those functions. So I'm going to have you do sine of 49 degrees, cosine of 23 degrees, tangent 74 degrees, cotangent of 19 degrees, cosecant of 43 degrees, and secant of 28 degrees. I'll have you start out doing those 6 trig functions quick, and we'll go over them in just a couple minutes. Okay, so let's take a look at these, see how you're doing. Well, sine of 49, that's pretty straightforward. Just sine 49, make sure I'm in degrees. I am not right now, so I gotta change my mode. Make sure I'm in degree mode. So sine of 49, 0.7547. Cosine of 23, again, just cosine 23, 0.9205. Tangent of 74, again, that's just a main function, so tangent 74 gives us 3.487. Just a reminder, we've mentioned it the last couple of classes, sine and cosine are always between -1 and +1. Tangent can be any value from -infinity to +infinity. Cotangent of 19 degrees, we hit the tangent of 19. And remember, when we're finding the function of the angle, if we have the angle and we're finding the function, We close the parentheses first and then put that reciprocal, or x negative 1, outside the parentheses, giving us 2.904. Cosecant, remember that goes with sine. So that's the sine of 43 degrees. Again, we close the parentheses and hit the x negative 1. 1.466. And secant goes with cosine. So it's cosine of 28. Close the parentheses and then hit that reciprocal. 1.133. And again, since cosecant and secant are reciprocals of the sine and cosine, it makes sense that their values always have to be either less than -1 or more than +1. Let's review going the other direction now. If I tell you that the sine of angle A equals 0.8833, cosine of angle B is 0.2118, tangent of angle D is 1.993, cosecant of angle E is 1.84, cotangent of angle F 2.75, and secant of angle G is 2.308. Find those angles A, B, D, E, F, and G. We'll go over those in just a couple minutes. So, first one here, the sine of A equals 0.8833. Find A, we're going to do an inverse sine, so just second sine, 0.8833, close the parentheses, and there it is, 62.04 degrees. Cosine B, we do the inverse cosine, 0.2118. We get 77.77 degrees. And for the tangent, it's just going to be an inverse tangent, 1.993, giving us 63.35 degrees. So those are the built-in functions of the calculator. The next ones are the ones that we have to adjust. Cosecant, remember, goes with sine again, so it's going to be inverse sine or second sine. We put in the 1.84. Now remember, when we're doing the inverse, the reciprocal goes inside the parentheses. So we do the x negative 1 key first, then we close the parentheses. We get 32.92 degrees. For cotangent, we're going to do the inverse tangent, so second tangent, 2.75, and then hit that reciprocal key, 19.98 degrees. And for secant, it's cosine, so second cosine. Put in the 2.308, and again the reciprocal goes inside the parentheses. We're at 64.32 degrees. So we were able to find those inverse functions, or find the angle if we know the value of the function, by using that process. There was one that we need to go back and note here. The sine. Sine of an angle being 0.8833. Because of the nature of the sine on the unit circle, we have to be careful. So 0.8833, that means that angle hit somewhere up in here. That's that distance, 0.8833. And what the calculator gave us is this angle right here. It said that is 62.04 degrees. But remember, we mentioned that idea of a reference angle. That is a reference angle. And there are actually 3 other angles in the unit circle that have that same reference angle. We have one here, this is 62.04. One here, that's 62.04. And one here, where that's 62.04. Well, these two signs are both negative because they're below the axis. So those angles don't cause any issue here. But this sign here is also a positive 0.8833. This reference angle here, 62.04, would correspond to an actual angle of 180 minus 62.04 degrees, or 117.96 degrees. So when we did that inverse sine here, we needed to know whether that was an acute angle or an obtuse angle. If it's acute, that's our answer. If it were obtuse, then it would have been the 117.96 degrees. Now, what we're going to be doing over the next couple of classes, we're going to be sticking to right triangles for now. So it's going to be the acute angle that we're concerned with. But at some point, we are going to move into those oblique triangles where that 117.96 is a possible answer. So all of these trig functions that we're talking about are most commonly seen applied to right triangles like this. So if I have, let's say this is 8 inches, 15 inches, and 17. Of course, the right angle is usually labeled angle C. We'll call these angles A and B. The sine of angle B. I'll remember sine is opposite over hypotenuse. Well, the hypotenuse will always be that side that's opposite the right angle. So 17 here is the hypotenuse, period. But the adjacent and opposite sides depend on what angle we're looking at. Here's angle B, which means the opposite side is over here. That's the 15. So sine of B is 15 over 17. 15 divided by 17 gives us 0.8824. Well, what good does it do us to know that the sine of that angle is 0.8824? Realistically, none, unless we're going to do something more with that. But from what we did up here, if we know the value of the sine, we can find the angle. So since we know that the value of the sine of angle B is 0.8824, we can go the next step, and since the sine of B equals 0.8824, we can solve that to get that angle B is inverse sine. Now, since rather than just typing in 0.8824, we had to round that. So I'm going to do this. I'm going to use the answer key. I'm going to do second ANS to tell my calculator to use that previous answer. So it's not just going to be 0.8824. It's going to be 0.8823529441. It's going to use that entire answer without rounding. Now it's 61.93 degrees. So by using the sides of the triangle to calculate the sine of angle B, we were then able to find the inverse sine of that function, of that value, and actually get angle B. Now for angle A, we know that angle A and B have to be complements. So we know we can subtract from 90, and this has to be 28.07 degrees. But let's look at how we would find that. I could use the sine of angle A. It's still opposite over hypotenuse, but for angle A, the opposite side is the 8 inches. Hypotenuse is still 17. 8 divided by 17 is 0.4706. And once again, that's telling us that the sine of angle A is 0.4706. We can use that to find that angle A is the inverse sine of that. So second sine, and again, I'm going to use second answer so I don't have to use the rounded value, is 28.07 degrees. Well, we already had that by subtracting, but it confirms that that is the correct angle there. So just having those trig functions allows us to find those missing angles. Now here, I had all three sides of the triangle, so I was able to choose what trig functions. I just defaulted to the first one in the keyboard of my calculator, which is the sine. But in many cases, we won't have all three sides. We might have a situation like this, where I might tell you that this is 20 inches and this over here 26 inches. And I want to find the measurement of angle B. So that little M is just saying measurement of angle B. To be honest, most of the time I would just say find B. You know it's an angle. Well, from angle B here, the two sides that I know, well, 26 is the hypotenuse no matter what. The 20, according to angle B, would be the adjacent side. So if I look in my list of trig functions, I find the trig function that uses hypotenuse and adjacent. There are two of them. One is secant. Well, in practice, we try to avoid secant as much as possible because it's harder to calculate because it's not one of the main buttons on the calculator. The other trig function that uses hypotenuse and adjacent is the cosine. Cosine theta equals the adjacent side divided by the hypotenuse. I'm going to put that information in there. Cosine of angle B then would be 20 would be the adjacent side over the hypotenuse of 26. Now I have been a little sloppy here. Technically that's 20 inches over 26 inches, But since those are both the same unit, it's going to cancel out anyway. And of course, the trig functions themselves are always unitless because the two measurements that we use have to have the same unit so that it does cancel out. Now, rather than dividing out the 20 divided by 26 to get the cosine, and then doing the inverse cosine, I can do that all together here. I can do second cosine, and then do 20 divided by 26, making sure I close the parentheses so the calculator knows that the whole value is 20 divided by 26, not the inverse cosine of 20 and then divided by 26. And we just hit enter. We get 39.72 degrees. So this is 39.72 degree angle. Find angle A. From angle A, this is the opposite leg. So I have opposite and hypotenuse. That goes back to being a sine. Sine of an angle is opposite over hypotenuse. So this would be the sine of A equals the opposite side is 20 over the hypotenuse of 26. So once again, I'm going to do an inverse sine. Second sine, 20 divided by 26. And again, I can do that division inside the parentheses so I don't have to divide it out separately. I get 50.28 degrees. This is 50.28 degrees. And those two angles do add up to 90. So it does come out to my total of 180 for the triangle. That is finding a missing angle on our triangle given the sides. There's one other possibility, of course. I could be given both legs. Like this. Might be told that this is 12 inches and this over here is 14 inches. If I want to find angle A, according to A, this would be the opposite leg, and this would be the adjacent leg. Opposite and adjacent make tangent. Tangent to theta is opposite over adjacent. Now, you'll notice I continually write down the definition of the trig function first, and then fill in the information. I actually highly recommend you do that when you're starting out, just because it helps you make sure you get all the numbers in the right place. So theta is the angle we're looking for. In this case, that's angle A. The opposite side is the 12 inches. The adjacent side is the 14 inches. And we're solving for A here. So this is going to be an inverse tangent of the 12 over 14. Second tangent, 12 divided by 14. Close the parentheses. I get, oops, second didn't register there. Let me try that again. Second tangent of 12 divided by 14. There we go, 40.60 degrees. Find B, angle B up here. Now the 14 would be the opposite, and the 12 would be the adjacent. So tangent of angle B equals opposite of 14 over adjacent of 12. That tells us that B is equal to the inverse tangent of 14 over 12. Second tangent, 14 divided by 12, 49.40 degrees. Now those two angles do add up to 90 degrees, so it does give us the proper angle sum for a triangle. Now we could at this point, in either of these triangles, we could find this third side because we have that very simple Pythagorean theorem from last semester. Little a squared plus little b squared equals little c squared. So here, the shortcut would be simply the square root of 12 squared plus 14 squared. We move that squared over to the other side and make it a square root. So we just punch this in, the second square root of 12 squared plus 14 squared. We get 18.4439 inches would be the length of that hypotenuse. Now, in this example up here, it would be slightly different because I gave you the hypotenuse in one of the legs, so it would be working backwards. This would be the square root of 26 squared minus 20 squared. $16.613. Now I realize here I took a lot of shortcuts. I didn't write out the whole, a squared plus b squared equals c squared, and put, a is 20, so that's 20 squared. B is what we're looking for, and c is 26, that's 26 squared, and solve it to get this. We've used the Pythagorean theorem before. We used it last semester. I'm assuming at this point you know it well enough that by me jumping to this shortcut, jumping to that step, it doesn't confuse you too much. If you do have questions on it, please let me know, and I'm more than happy to go back and work through that for you. But at this point, that's one of those tools that we've used enough. We're going to try to take some shortcuts to make it work a little quicker for us. Well, outside of having two known sides and being able to just use that Pythagorean theorem to find the missing side, how would we find the missing sides of a right triangle? So we have that right angle, and let's say I tell you that this angle over here is 27 degrees. And I give you that this side over here is 32 inches. I'll call this angle A and B. Now the labeling of the sides, we label the side according to its opposite angle. So this is side little a because it's across from or opposite angle big A. This is side little b because it's opposite angle B. And the hypotenuse is side C. So here I have the 27 degree angle. Now, of course, by simple subtraction, I would have here that B has to be 63 degrees. That's just by doing 180 minus 90 minus 27 leaves us with 63 degrees. Or we could just use that these two angles have to be complements. To find the sides A and B, I have to use a trig function. So first we're going to pick a side that we want to find. Let's find side A first. Next, we have to decide which angle we want to use to find it. Now, I just calculated angle B. I'm actually going to go back and I'm going to use angle A. There's a reason for that. This is the engineer in me coming out. Mathematically, it doesn't matter which one you use. But from the engineering side of things, angle A was given to me as 27 degrees. So if I use that 27 degrees and something is wrong, at least I'm using information that somebody else gave me. And if that 27 is incorrect, it's not my fault. It sounds like kind of a cop-out, but using the information given to you, the only chance for error is your own calculation. You didn't screw up something else to start it off with. The 63 here is something I calculated. If I use that 63 and it was wrong, well, then it's my fault. I calculated it wrong. I'd rather go back to, I'm not wording this real well here. I'd rather go back to given information rather than using information I've already calculated, because every calculation is a chance for me to make a mistake. So by going back to the 27, I'm taking out one chance for a mistake. The 63, even though that was a pretty simple calculation, I calculated that, and there's that small chance that there was a mistake in that calculation. So rather than deal with that extra chance of mistake, I go back to that given information, the 27 degrees. So according to the 27 degrees, the side I have, the 32, is the hypotenuse. In fact, it doesn't matter which angle I'm looking at. That side, the 32 inches, is the hypotenuse, period. The side I'm trying to find, side A, would be the opposite side. So I have opposite and hypotenuse. That is sine. Sine of theta is opposite over hypotenuse. Then I fill in the information I have. Here I know that the angle is 27 degrees. The opposite side, that's side A, that's what I'm trying to find. And my hypotenuse is the 32 inches. When I'm dealing with trig functions like this, up here when I was missing an angle, it was just a matter of setting it up and then doing the inverse tangent, inverse sine, whatever inverse of whatever trig function I was using. Here, however, when I know the angle and I'm trying to find the missing side, it helps to go back to that definition of the trig function we had last week, where the trig function is actually over 1. What this does for us is this creates a proportion. To solve for this missing piece here, which is just the A up here, I'm going to do what I would for any proportion. I'm going to cross, multiply, and divide. Sine of 27 times 32 divided by 1. So on my calculator, get up here. I do sine of 27, close the parentheses, times 32, and divide by the 1. I get 14.53. Now, very important there, sine 27, I had to close that parentheses before I did multiplied by 32. On most calculators, it's very important to put in that close parentheses. So 18 is 14.53. So A here is 14.53 inches. Now, I could find B by doing A squared plus B squared equals C squared. But again, that would require me to use this 14.53 that I calculated. And rather than reuse a result of my own calculation, if at all possible, I try to go back to original information or given information at each step. So to find B, B here would be the adjacent side, if I'm still using angle A, the 27 degrees. So adjacent and hypotenuse, that would be cosine. Cosine of theta equals the adjacent side over the hypotenuse. And we plug that in. So the angle here is 27 degrees. The adjacent side is B, that's what I'm looking for. And 32 inches is the hypotenuse. So once again, I put that over 1, and I cross, multiply, and divide. So cosine of 27. Again, it's very important that I close that parentheses, and then times 32 divided by 1. Now, we all know that dividing by 1 doesn't do anything, so you can skip that if you want to. I get 28.51 inches. So B here is 28.51 inches. Before I move on to the next example, a couple of things to point out to double check. We know that in a right triangle, the hypotenuse should be the longest side. In this triangle, it's 32 inches. So these two legs that we found better both be shorter than 32 inches. Here they are. So that is a good sign. Now there's another obscure rule in a triangle that we haven't talked about yet. And that is the two shorter sides have to add up to be larger than the longest side. A plus B has to be larger than C by itself. 14 and 28 is 42. That's definitely larger than 32. So those are two little things we can do to double check. It doesn't guarantee us we may have the right answer, but it would catch some of the really bad mistakes that we could possibly make out there. So here on this right triangle, again, I'll call it A, B, and C. If I tell you that this angle here is 68 degrees, and this side right here is 15 centimeters. Of course, that side little a, this would be little b, little c. First off, of course, I can find this angle here by just subtracting. 180 minus 90 would be 90, minus another 68 is 22 degrees. But again, I always want to try to go back, if I can, to given information for each calculation. So I'm going to use the 68 degrees for finding my missing sides. Next, I need to decide which side I want to find first. Let's find side B first. So what I have here, according to that 68 degree angle, the 15 that I'm given is the adjacent side. B that I'm trying to find is the opposite side. So that's going to be a tangent. Tangent of theta is opposite over adjacent. So I'll plug in my numbers here. I have 68 degrees as my angle. Opposite side is side B, that's what I'm looking for. Adjacent side is 15 centimeters. So I make it a proportion again, putting my trig function over 1. And just like before, I'll cross multiply and divide. So tangent of 68, again, it's very important to close that parentheses, times 15. And like I said, we don't have to divide by the 1. 37.13 degrees. Or 37.13 centimeters, I should say. So B is 37.13 centimeters. Now, once again, I could find C by doing A squared plus B squared equals C squared. But that would require using something I've already calculated. And if we can, we try to avoid that. We try to go back to original information. So C would be the hypotenuse. So I'm finding the hypotenuse. And again, I was given the adjacent side. That's a cosine. Cosine of an angle is adjacent over hypotenuse. So my angle is the 68 degrees. My adjacent side is the 15 centimeters. My hypotenuse is side C. That's what I'm trying to find. So I make it a proportion and I cross multiply and divide. So here's one where that proportion makes it a lot easier because we're solving for something that is on the bottom of a fraction. So this is 1 times 15, which is just 15 centimeters, divided by the cosine of 68 degrees. So divided by a cosine of 68, we get 40.04. So that hypotenuse is 40.04 centimeters. So finding these missing sides, missing angles, it's a matter of being very meticulous about identifying what each side stands for. Is it the hypotenuse, the opposite, the adjacent? And then using what we know and what we're trying to find to figure out what trig function applies to it. Now, there are a couple of things out there for us. There is a quiz on Blackboard for us for today on the basic trig calculations. Then there is homework of a packet I've got posted out there for you. Page 351 through 354, finding the missing sides of those angles. Or those triangles, I should say. And with that, we have about 11 minutes left here. I'll let you have that time to get started on your homework. I will be on the network here for a while to answer any questions if you need them.